Welcome everyone. In this video, I will discuss about the main objectives of Aditya L1 satellite. Aditya L1 is a 400 kg PSLV satellite launched by ISRO on 5th of September 2023. It is a second solar mission after AstroSat, which was launched in 2015. Aditya L1 has 7 payloads on the board that are capable to do the scientific investigations like solar winds, solar flares, corona, magnetic field and CMAs, meaning coronal mass ejections. In this video, the main objective is to study about the parts of Sun and their interesting facts. And at last, we will know about the meaning of L1 named on the satellite. Let us talk first about the Sun. The Sun is a middle-aged plasma star that is composed of 70% hydrogen and 28% helium. Over the time, hydrogen is converted into helium in its core by thermonuclear reactions. The core of Sun is the innermost layer surrounded by the radiative and convective zones. The atmosphere of the Sun is divided into 3 parts. The first part is photosphere. Photosphere is a thin layer of gas from which Earth receives most of the Sun's light. Below this layer, the gas is so much dense that it radiates huge amount of light, but it cannot escape as it is blocked by the outer layers. So Earth does not receive light from these layers. Photosphere is only 500 km thick and has temperature around 6000 Kelvin, that is much cooler than the Sun core. It is in state of constant motion, like water boiling in a closed container. The bubble formed in the layer are called granules. This part we can clearly see through our naked eyes as it radiates visible rays. The next layer after the photosphere is called chromosphere. It has temperature about 20,000 Kelvin. During the total solar eclipse, the new moon comes in between Sun and Earth. So, all the sunlight gets blocked by the moon, but a reddish ring of light we can observe around the Sun's photosphere. It is called chromosphere. The density of this layer is so much less than the air we breathe and is hot enough to emit the X-rays. We study this layer through X-ray telescopes in the space. Studies revealed that in this layer, atoms is highly ionized. That means they lost all the electrons. The outermost layer of the Sun, it is called corona, which is so dim that we cannot see it through the Earth as light is blocked by the previous 2 layers. The temperature of this layer is around 5 lakh kelvins and is hot enough to emit the X-rays. Solar winds originates in the corona, which is a flow of gas away from the Sun atmosphere at a speed around 100 km per second. Due to this, Sun is slowly lose its mass, but that is negligible than its total mass. Astronomers also studied dark sunspots on the Sun photosphere that disappear over the time. The intensity of this space during its cycle also affects Earth's climate, and it is caused by magnetic fields produced by the Sun due to the movement of ions. The number of spots visible on the Sun varies in a cycle with a period of 11 years. At the maximum, we see over 100 spots on the Sun. In early cycles, spots appear at high latitudes of Sun's equator, then they come close. So if we plot a graph between latitude of sunspots versus time, they looks like butterfly wings. The Sun magnetic field is not stable like as that of the Earth. The flow of magnetic field in the Sun is inward and the solar flares in outward direction. So both meet each other and we call that a reconnection event. In this event of meeting, electric current of millions megawatt is created and excites atoms of upper atmosphere of Earth to emit the photons. Seen from the Earth, they look like gaseous clouds about 130 km from us. We call it auroras, or popularly called northern lights. Reconnection events can release enough energy to blow large amount of ionized gas outward from the corona. We call them CME, means coronal mass ejection. If CME strikes the Earth, it can violently disturb the Earth's magnetic field. At last, we will study about the meaning of L1 used in this satellite. In the 18th century, Euler and Lagrange discovered that there are 5 positions in a 3-body problem in rotating frame where if we put an object, it remains stay there. These 5 positions are called Lagrange points, numbered from L1 to L5. Theoretically, L1, L2, L3 lies on a single line, while L4 and L5 form an equilateral triangle with 60 degrees apart. Also, L1, L2 and L3 points are unstable, but they are useful to us because a spacecraft is made to execute a small orbit about each Lagrange point so that it maintains its fuel. The orbits around L1 and L2 points are called halo orbits, named by NASA scientists, while orbit L3 is on opposite side of Earth from the Moon. So it is not easy to use, as if we place the satellite there, we cannot communicate with it. Scientists place their probes at L1 point to monitor the sun, and L2 point for the survey of infrared and microwave sky. Points L4 and L5 are stable, but under a certain condition, and that condition was the ratio of mass of planet to the satellite should be more than 25. At these points, various Jupiter or the Saturn asteroids meet. So placing the satellite at these points is dangerous. Now Aditya L1 satellite is put on the L1 orbit, which we call as halo orbit, so that we can easily monitor the sun. Thanks for watching. For more such videos, please subscribe to the channel.